Every galaxy in the universe needs dark matter to hold itself together. Every single one. Until astronomers found one that didn't. A galaxy roughly the size of our own Milky Way, spinning, staying intact, doing everything gravity says it shouldn't be able to do without it. It shouldn't exist. And yet, there it was. Welcome back to the Cosmic Vault. This is the story of NGC 1052-DF2 and why it might be one of the strangest, most important galaxies ever discovered. First, a quick reason this matters so much. Dark matter isn't just some extra ingredient astronomers sprinkle into galaxy models to make the math work. It's considered the scaffolding that galaxies are built around. Based on decades of observation, normal, visible matter, stars, gas, dust, simply isn't enough on its own to explain how galaxies hold together and spin the way they do. Something invisible has to be providing extra gravity, and in nearly every galaxy ever studied, dark matter appears to outweigh normal matter by a factor of roughly 5 to 1. It's considered one of the most fundamental, reliable rules in modern astrophysics. Every galaxy has it. That's not an opinion. That was, until recently, treated as close to an observational fact. In 2018, a research team led by Yale astronomer Peter Van Dokkum was using an instrument called the Dragonfly Telephoto Array to survey faint, diffuse objects in the sky. One object caught their attention because it looked strange in two different surveys. In one telescope, it appeared as a smudge of soft, diffuse light. In another, it looked like a scattering of individual bright points. That mismatch was the first clue that something unusual was going on. Follow-up observations using the Hubble Space Telescope and the Keck Observatory in Hawaii confirmed what they were looking at. This was a real galaxy, roughly the same physical size as our Milky Way, but almost transparent by comparison, containing around 200 times fewer stars. Astronomers called this kind of object an ultra-diffuse galaxy. It earned the catalog name NGC 1052-DF2, DF2 for short. Here's where it gets genuinely strange. To figure out how much dark matter a galaxy contains, astronomers usually measure how fast objects inside it are moving. In this case, a population of dense star clusters called globular clusters, orbiting within the galaxy. If a galaxy is packed with dark matter, that extra invisible mass creates extra gravity, and objects inside the galaxy move faster than the visible matter alone could explain. When Van Dokkum's team measured the velocities of DF2's globular clusters, the clusters were moving slowly. Too slowly. Slowly enough to suggest that the visible stars alone were providing basically all of the gravity holding the galaxy together. The dark matter, the invisible 5 to 1 majority that every other galaxy seems to require, appeared to be almost entirely missing. Naturally, the astronomy community's first reaction wasn't excitement. It was suspicion. An enormous number of these calculations depend on knowing precisely how far away a galaxy actually is. Get the distance wrong, and every mass estimate built on top of it gets thrown off too. Several independent teams spent the next few years trying to poke holes in the result, arguing the galaxy might actually be closer than originally measured, which would have quietly restored its missing dark matter and made the whole mystery disappear. It didn't disappear. In 2021, Van Dokkum's team went back with 40 separate orbits of Hubble Space Telescope time, specifically to nail down the distance using a precise technique involving the brightness of a certain type of aging star. The refined measurement confirmed their original distance almost exactly. In Van Dokkum's own words at the time, the result held up, quote, beyond any shadow of a doubt. And DF2 wasn't even alone. That same year, the team identified a second galaxy nearby, catalogued as DF4, showing the exact same dark matter deficiency. Whatever process created this effect in one galaxy had apparently done it twice, in the same small patch of sky. So what's actually going on? A few explanations have been proposed, and this is where the story gets genuinely interesting instead of just confusing. One leading idea involves tidal stripping. Both DF2 and DF4 sit near a massive elliptical galaxy called NGC 1052. Some researchers have found evidence, including a faint stream of stars trailing away from DF2, suggesting the smaller galaxy may have passed close to its massive neighbor at some point in its history. If dark matter is distributed more loosely around a galaxy's outer edges than the visible stars are, a close gravitational encounter could theoretically strip much of that dark matter away over time, while leaving the more tightly bound stars largely intact. But here's the part that makes this discovery matter far beyond just one weird galaxy. For years, some physicists have argued that dark matter might not be a real, physical substance at all, and that our theory of gravity itself might simply be wrong at galactic scales, an idea generally referred to as modified gravity. If that were true, every single galaxy should show the same gravitational anomaly all the time, without exception, because gravity itself would be behaving differently everywhere, not just in specific places. A galaxy like DF2, one that behaves almost exactly the way normal Newtonian gravity would predict, using only its visible stars, is very difficult to explain under most modified gravity models. It's actually much easier to explain if dark matter is a real, physical substance that can, under the right violent circumstances, be separated from a galaxy's ordinary matter and stripped away. In other words, the galaxy that seemed to break the rules of dark matter may have ended up doing the opposite. It may be some of the strongest evidence yet that dark matter is a genuine physical thing, not just a mathematical patch for gravity we don't fully understand, because you can apparently take it away from a galaxy and leave the stars behind. Astronomers are still studying DF2 and DF4 closely, still searching for more galaxies like them, and still debating the exact mechanism behind what happened. But one thing is no longer seriously in question. Somewhere out there, 65 million light-years away, sits a galaxy that looks almost exactly like it should, made almost entirely of the part of the universe we can actually see. This has been the Cosmic Vault. If galaxies breaking their own rulebook is exactly the kind of thing you want more of, hit subscribe. The next one drops in a few days, and it's just as strange. See you in the next one.